let's get started. So I was gonna say a few things for the nomenclature when you guys are naming things. Usually if it's gonna end in ate or ite, it will usually most likely be a polyatomic ion. Like the exception will be hydroxide. It ends in IDE, but that's still a polyatomic ion. Ide is usually an element off the periodic table like IDE. And then you guys should know the subscript is a number that represents how many of the element there is. That's why I'm saying, like, if it's an ionic bond, you guys have to make sure to cancel out those charges, because when two ions come together, they're going to form a neutral charge. And then, so I do have some practice problems for you guys that you guys should probably do. So you guys could get a little bit more practice, because he does have.
Wait, I can't hear you. I don't know if anybody else can hear you.
Oh, you guys can't hear me?
No, I can hear you.
I can hear you.
I can hear you.
Am I
You're good.
talking too far away from my mic?
No, you're good. You're good. I can hear you clear.
Everybody can hear?
Yeah, you're good.
Okay. So if you guys want to just do some of these practice problems, hold on. Wish. Stay with me. So what would this first one be?
Let me get my stuff out and then I'll answer.
Yeah, you guys should have your periodic table, your polyatomic ions out, because I do have a few more different practice problems too, like for dimensional analysis, for the heat problems, stuff like that. I'm not going to review balancing chemical equations because everybody seems to be pretty familiar with that. So I wanted to review stuff that you guys are struggling with a little bit more. Was that right? Is everybody good on balancing chemical equations, right?
Yeah.
Yes.
Yeah. Okay.
Is this ammonium chloride?
Yeah.
Okay.
Ooh. And what about the next one?
Iron nitride. That's just a guess. Iron nitride.
So what is iron? Is it a transitional metal?
Oh, iron. Oh, and then is this where you have to put the Roman numerals?
Yeah. And what would the Roman numeral be?
Let me just. Nitride. Iron has a. So nitride has a number 3. Iron has a charge of. What the hell is my thing here? Oh. Hold on. But I'm not sure. I want to guess 3, but that's just a guess because I'm not
Yeah,
sure.
no, that's right. And the way you can tell that though is let me do this. Is because of this right here. Oop, dang it. Hold on. I'm messing up. Undo that. It's because of this right here. That's telling you that for every 1 iron, you need 3 nitrate to balance it out.
Okay.
And if you remember, nitrate's a -1 charge, so that means iron has to be +3.
Okay, and I thought so too, but honestly, it was just a good guess.
Here.
Iron 3 nitrate.
But I don't want you guys to get confused with like this, with this one right here.
Mm-hmm.
This 3, because that's just telling you that's 3 oxygen in the nitrate. You know what I mean? That's
Mhm.
why it's like, if you have the polyatomic ion, it has to be in parentheses for it to represent that it's that whole thing. If that makes sense.
Yeah.
Because I know some of you guys were saying like this would be the charge. I mean, this in this case, they happen to be the same.
Mhm.
But in sometimes it could be iron 2 nitrate, which would mean that this outside one will be a 2 instead of a 3, right?
Mhm.
What's the next one?
Oh, again, the same thing. So it'll be titanium. Let me see, it has a -1 charge. Oh, titanium 3 with bromide. Bromate. I think.
Bromide, yeah.
Bromide. That's right.
Alrighty. And what's the next one?
Where's Ivan? I think he know these.
I know you're the only one responding.
I
I'm
know.
still settling in a little bit.
Oh, you're gonna need your coffee.
Yeah, I was getting my coffee and everything.
You guys were here before. You guys were on before I was.
Yeah. When you took a little bit, I kind of went off just because I was like, okay, it's gonna be a second. But I'm ready. I'm ready now.
Yeah, let's just do it because honestly, I'm like, tired of being the only one. Okay, so this one is
Is that one gallium arsenide?
Gallium arsenic.
Arsen, oh, it's arsenide, right?
Yeah.
okay, is that Brenda?
I could spell. I don't know if I spelled it right, but
Maggie.
all right. And then
Gallium,
since you guys are getting the hang of these, we'll just do this one. Oop. We'll do this one, and then we'll skip these two,
Mhm.
and then we'll probably do a couple of these. So you guys, because you guys have to know the chemical name and the chemical formula. You're gonna have to go from one to the other and back.
Mhm.
Is it multiple choice or do we have to like actually type it in and answer it?
From what I saw, one of the questions on there was you had to actually like write it down, take a picture, and upload it.
Okay, cool.
But it was like worth 6 or 7 points because it was like 6 of them in that one question.
Okay.
All right, so what's this one?
Beryllium hydrogen carbonate.
Oh.
You hear that, Maggie?
Is it hydrogen carbonate?
Carbonite.
Let's see. Yeah, carbonite.
And then
No, yeah, carbonite.
for this one, we're just gonna do this one and this one.
Okay.
Since you guys seem to be getting the hang of it. So
Mhm.
what's the chemical formula for chromium 4 phosphate?
Gonna be CR. I don't know the charge just yet. I'm figuring it out, but I know CR so far.
Is that number 6 or 4? Because I don't really know.
No, that's 6. I lied. That's
Okay. I was
yeah,
all,
the radium is 4, chromium is the 6.
Yeah. And then wait, where's my phosphate? Is it? Oh, this
Is it, if it's phosphate, it's gonna be PO4
4, 3.
2.
2.
Right? If it has a, because it already has a -3 charge.
The phosphate does?
Yeah.
Would it be PR or PO4 and then apostrophe in between, or the comma in between, or the apostrophe, and then have 2 on the outside?
Oh yeah, sorry, that's kind of what I meant.
Parentheses.
The
Yeah, the
parentheses,
parentheses.
yeah.
And then the 2 right here. Yep.
Yeah.
So that will help balance out the charge. All right, what about this next one right here?
That is going to be. Where's my data? So, V. What's it say? Where's carbon?
Would it be VCO3 and then the parentheses with the 2 on the outside?
BCl,
I don't think it
CO,
has to have CO.
CO3,
CO3,
yeah,
and then parentheses and the 2 on the outside.
yeah,
Is carbonate a 2- charge?
yes.
Yes.
Okay. Then yeah, that's right. Oh, so you guys got the hang of the nomenclature pretty well. Did those
Yeah.
labs did that lab help?
Yeah, and then just lots of practice and study.
Yeah. Okay.
Is there for this like slideshow, is it like linked in the modules or something?
For this one,
no?
no.
Yeah.
This is the one I
Okay.
created for today specifically.
Uh-huh.
If you guys want, I could email it to you guys.
I don't think it'll hurt.
I just didn't because I didn't know if you guys would actually want it.
Can you email it to us so that way we can also go over it by ourselves afterward?
Yeah, that's not a problem. I can do that.
Thank you.
All right. So you guys should know some of the periodic table trends, like electron activity is the ability to take electrons. Ionization, it's technically the ionization energy is technically the amount of energy it requires to remove electrons. But I remember as ionization as the ability to keep electrons. So like fluorine has a really strong electron activity. So not only can it take electrons, but has a really strong ionization, which means it keeps its electrons. It requires a lot of energy to remove those electrons. And those are things that like the periodic table trends, you guys are going to have to know because it will help with your, especially like on your later tests and stuff like that. And you guys should already know the atomic numbers, the number of protons, the mass is X amount of grams per 1 mole. And the mass is, we use grams, but it's technically atomic mass unit. So it's in AMU. All right, so like I have the arrow pointing up. Hold on, let me draw it. Because this is the way that the electron activity goes. It gets stronger as you go up and to the right. That's why fluorine has the strongest one. So if you see, like, if it's asking which is the most polar bond, hydrogen fluorine or hydrogen and fluorine are going to be the most polar because fluorine itself has like a 3-point-something electron activity. However, for atomic size, it goes the opposite. So this guy, francium, is going to be one of the biggest elements that we have. But the more important ones are the electron activity for you guys specifically, because you will be asked what's polar, what's not, and then even with the partial charges and stuff like that. So you guys kind of have to know who's the strongest at taking the electrons. Does anybody have any questions so far? I'm kind of going fast, but
No, I'm okay. That one, the electron activity, I think we just went over yesterday, so I'll have to do some more like setting and stuff like that, just to be
Could you-
certain.
yeah, I mean, like I said, I remember electron activity as the ability to take electrons.
Yeah.
And ionization is the ability to keep them.
Okay.
Could you give us some examples of like polar and non-polar?
Yeah. All right. So like hydrogen and carbon, if you go to here, let me actually. Can you guys still see my screen, right?
Yeah.
Okay, good. Okay. Because I have P table open right here. So like if I clicked on hydrogen and I go over to the electron activity right here, it's 2.20. And I go to carbon, that's 2.50. So if you do 2.55 minus 2.0, here, let me do that math right here. So it'll be 2.55 minus 2.20. I know I'm terrible at writing. I'm sorry, guys. So that will just only be, 0.35. So technically
Okay.
that's would be a non-polar bond because it's less than 0.5.
Okay.
Whereas typically things like, let's see.
Where did you get
Like-
the 2.55 from?
Oh, for carbon, it tells you on the P table, the electronegativity is the exact number. I don't think you'll be able to use P table on the test, but
No.
if he wants you to specifically know the electronegativity, he'll give it to you.
Okay.
Oh, yeah. So
And
you
it-
would just minus that electron activity against, would you get the 2.20 from?
That was the one from hydrogen, the electronegativity.
Okay.
Yeah, that's what it is. But you guys should know the trends, because sometimes what he does is he'll put one polar bond on there and the rest will be non-polar. But if you know the general trend, you could look at it and just know that, oh,
Okay.
this is the polar bond. Like I said, hydrogen, if you see anything with HF, that's automatically polar. Boron is not really that electronegative. So if it's compared with hydrogen, if you see HB, it's not gonna be polar. If you see HC, like the hydrocarbon, because carbon's not electronegative really, it's only 2.50 and hydrogen's
Mhm.
2.20. So that's not gonna be really polar at all either. If that makes sense.
Yeah.
Typically
have
when
to
you
check.
see, but like I said, the polar and non-polar are only for covalent bonds. So it's gonna be
Okay.
usually between two nonmetals.
Okay.
So you won't get a lithium chloride that's a ionic bond. So there's no way that if you see lithium chloride and it's asking if it's polar, that's obviously not, can't be it.
Yeah.
Usually with polar and with ionic bonds, it will be one of these metals right here, mostly with one of these halogens usually. But it's also like it's just a metal and a non-metal.
Okay.
Because he will try to trick you. He will put a ionic bond on there, like
Sure.
asking if it's which one's polar. So like lithium chloride or sodium chloride, obviously none of those could be polar because they're ionic.
Mhm.
Hold on, let me try to. Man, Dr. Henry makes this look so much easier. All right. Does that make sense?
Yeah.
Yeah, but I would really make sure you study the periodic table trends, because it does help a lot if you have a good understanding of it, to be honest.
When you say the periodic table trends, like what are you referring to?
Mostly like the electronegativity, the ionization, like hold on. Okay. So this guy right here, fluorine, he's gonna, since he has a high electronegativity, he's also has a strong ionization. And hold up, if I click on it, it will tell you that on here.
You know we can't see your screen, right?
Oh, you can't see my screen?
No, I thought you were just talking. I was like, girl, we have to just use our
Hold up.
imagination.
All right, I'm gonna share that. I thought you guys were looking at my screen this whole time.
I thought you were just talking about what you were writing down.
Yeah, me too. I was like, okay, girl, hold on.
No,
Oh,
I was
okay.
trying to give you an example.
Okay, go one more time. Fluorine.
Yeah. Oh my goodness. Yeah, you guys, if you guys can't see anything, just tell me, because I know like it's kind of hard for me to explain it. So that's kind of why I want you guys to be able to see it. You know what I mean?
Yeah.
But anyways. Okay, now that makes sense to why you guys were asking me how I was getting those numbers. But yes, like for P table, it gives you the electronegativity, like right here.
Mhm.
You guys can see my screen now, right?
Yeah.
Yeah.
Okay. So yeah, if you go on P table, it gives it to you right here, and you just click on the one. What did I do?
Oh.
I think you just clicked on electronegativity. If you click off of it on the left, it won't
Yeah.
show it anymore.
Wait, what?
Oh, it's just showing the electronegativity for all of it now. I think it's because you clicked it.
Oh,
I'm
that's
not
awesome.
sure.
I mean, that's helpful, to be honest. I
Yeah.
didn't even realize, because it just went completely different color, and I was like, what the heck's going on now?
Mm-hmm.
But you could see how fluorine right there has 3.98 electronegativity. And all these other ones are, like the oxygen has a pretty strong electronegativity. So does chlorine.
Oh, but it's showing fluorine as the strongest one.
Yes, and also has the highest ionization energy too.
Yeah.
See, this is the ionization one. If you notice, fluorine also has, so like fluorine's ability to take electrons is strong, and the fluorine's ability to keep them is really strong as well. Because this is the energy required to like try to remove the electrons.
Okay.
Fluorine wants to take electrons and does not want to share and give them up, basically. But the electronegativity is super important for you guys.
Okay.
Because he will ask about what's polar, what's non-polar. And like I said, like if it's lithium chloride or sodium bromide or anything like that, it's neither. It's gonna be ionic. So you guys have to know the difference between covalent and ionic, especially. Because he will try to throw some questions on there, like which one is a non-polar bond, but he'll also have ionic bonds listed as one of the possible options. However, I will say typically if it's hydrogen, any of these or these, it's going to usually be non-polar, because if we could tell, their electronegativity is pretty low. Oh, sorry.
Okay, so it has to be non-metal with non-metal.
Yeah.
Okay.
So anything with hydrogen and any of these guys over here,
Okay.
pretty much.
Okay. Yeah.
And then I'm not sure how, if you guys need to know, what is it? The size of it, but it goes the opposite direction. I will let you know that. It's
Oh,
Francine.
I think he did go over that yesterday.
Yeah. So like it's gonna go. This is gonna be the biggest right here. Because like that's why you're decreasing in the ionization. It's because iodine's much bigger than like fluorine. So he doesn't mind. He doesn't have to take electrons, and he doesn't mind getting rid of electrons either. because he's already really big and he's so spread out that it doesn't matter. You know what I mean?
Yeah.
Mhm.
And like I said, I'm not too sure. He might have some questions on that. I don't know if it'll be on this test or the next test, but I know for sure that knowing the electron activity is super important because he will ask you questions on that.
Mhm.
Okay. So isotopes, you guys should know, is they're the same number of protons. The protons define the element. So if you have one proton, that's hydrogen. If you have two, that's helium. So that's why the isotopes will always have the same number of protons. The only way they will differ is the mass because they have different neutrons. Polarity is the difference of the electron activity, which I kind of went over a little bit. Like hydrogen, hydrofluoric being the most polar. And this could only happen, like I said, in covalent bonding. They have to be sharing electrons. And oh, I do want to say, because I know some of you guys were asking me about it yesterday, about like which one will be the positive, I think, what is it, like the positive field? I think that's what it was. And which one will be the negative? Okay, so the one that will be negative will usually be the one with the strongest electronegativity. In this case, it'll be fluorine. Because fluorine's so strong, he's gonna hog up these electrons that they're supposed to be sharing. So fluorine will become partially negative and hydrogen will be partially positive because fluorine's gonna be hogging up the electrons most of the time and hydrogen will get them like once in a while when fluorine's being nice, basically, you know what I mean? So typically I would look at, that's why it's easier to, if you learn the periodic trends, because then if you know like which one's gonna be like on the negative field or whatever, if fluorine's on that list, obviously fluorine's gonna be there because he has the strongest electron activity. Oop, dang it, just forget it. So you guys should already know about the orbitals, shells, and subshells. I did see the first time I looked at your practice exam, I did see like questions like this. How much, like how many can the p orbital hold or how many can the d orbital hold? So you guys should know that. There's in the s orbital, there's only, or in the s subshell, there's only one orbital, which is why it could only hold two. In the p, there's three. Here, let me see if I could draw it out. So the S subshell, it will usually look something like this. That's the S subshell. Then you have the P. Then you have the D, which will have 5. And the F, which will have 7 orbitals. And each one could hold 2 electrons. 1, 2, 3, 4. 4, 5. Well, I don't have to draw them all out. And the reason why like hydrogen and helium are only happy with 2 electrons is because they only have this one orbital. So they can't hold more than 2. All the other ones will want to fill it up. What they want is all 2 on every orbital if they can, basically. And I did see, I don't know if he took it off, but when I looked again, he didn't ask the question, but it's about which orbital has the most energy or requires the most energy. Did you guys see anything like that on your practice exam when you guys did it?
I didn't see anything like that.
Interesting. Well, I know like it's different, a little bit differs from everybody, including me, so. Ugh. And you guys already did electron configuration. Are you guys feeling pretty confident about that?
Yeah, I am.
Do you guys have any questions? Anybody?
No, I'm just kidding.
Okay, well, if nobody has questions, I'll just move on then.
Mhm.
I did have these practice problems, but if you guys are feeling pretty confident about it, then you guys don't need to do these.
Mhm.
All right, so for the isoelectronic, it is it's like the different ions or elements that have the same number of electrons, or the valence electrons. That should be a little bit more specific. Like for example, these guys all have 10 valence electrons. So that means they're all isoelectronic. Do you guys know? You guys know what I'm talking about when I say valence electrons, right?
Yes.
Okay. Okay. So to make sure. And I know you guys actually went over the Lewis diagram, so I could explain it a little bit. When you count the valence electrons, you only count the S and P shell. So you don't count the D shell. Like, oh, dang it. Let me give you guys an example. Share this. Share. Okay. So like if you want to count the valence electrons for antimony, it would just be 1, 2, skip these, 3, 4, and then 5. So like everybody in this row will have 5. Everybody in this row will have 6. Everybody will have 7 here. I mean, honestly, I just ended up memorizing them because it was like 1 all the way down. Same thing with the charges. 2 all the way down. 3 and goes all the way down, and then 4 right here. All the way down. And then for all the transitional metals, you only count the S and P. So there's only S right here. So all these guys will only have 2 for all of them. You guys remember that? Or did he talked about that, right?
Yeah.
Okay. So yeah, counting the valence electrons shouldn't be too difficult because you only count the S and P. Like this row and this one right here. Or you can just memorize them because they'll be like literally in order. It'll be like 1, 2, 3, 4, 5, 6, 7.
Wait, so even for the D subshell, we're counting the S and P?
No, you'll just be counting the S.
Just yes. Okay, okay.
Yeah, that's why all the the transitional metals right here will only have 2 valence.
Okay, okay, that makes sense.
Yeah, because you're only counting the S. All right, let me switch back. And then you guys know what single, double, and triple bond are, right?
Is that the one like where you put the like electrons in the middle and they share or something?
Yes, yes,
Okay.
that is true. And then
Good
you
to
have to know for each bond, like for the single bond, it's 2. So for double,
Yeah.
4, for triple, it's 6.
Yeah.
Like each little line is 2 electrons.
Mhm.
As a matter of fact, for your class, most of your Lewis diagrams, you're gonna have lone pairs, which will be a pair of 2 electrons that are represented as like little dots, you know? And then, or
Yeah.
you'll have these, like a line. that represents 2 electrons.
Mhm.
Typically though, like if you go to higher chemistry, you'll also learn radicals with just 1 lone electron by itself, but that's a whole nother thing.
Mhm.
You know, I would love to be able to do, hold on, let me figure something out. That's not it. Okay. Oh, no.
Do you know what chapters this exam's going over? Is it 6, 8, 11, and 12?
Yeah.
Okay.
Dang it. Yeah, that sucks. I don't know how to use the whiteboard on here. So I could actually just write it out. If I can't share it. Hold on. Alright, I'll figure it out. Now I will say though, for the Lewis diagrams, you do have to be careful of something if you have a charge associated with it. Like for example, let's say you have ammonium, right? That's NH4, and then but has a charge associated with it, just a plus. So that means it's gonna have 1 less electron than you think it is. Believe nitrogen should have 5. Yep, 5.
Yeah.
Damn, I can't believe I still have all that stuff memorized.
Mhm.
Anyway, you guys still see? You guys can see my screen, right? Like the whiteboard.
Yeah.
Okay. So nitrogen is supposed to have 5, and hydrogen will have 1 each, but there's 4 of them, so it's gonna be 4. So technically, in total, that's supposed to be 9. However, because it has a plus, it's gonna you have to subtract 1 electron because that means it lost an electron. So that means you
Okay, got
only
it.
have 8. So that means when you do it, it's going to be nitrogen, of course, in the middle. Then you have hydrogen, hydrogen. Yep, 8 electrons. Let me put E. There we go. And hydrogen. And that's actually all the electrons you could use. You can't, honestly though, like you have to find out how many valence electrons you have to start with, because you can't use any more, you can't use any less. It has to be the exact number of valence electrons you're supposed to have, or you have. So since I have 8, it's 2, 4, 6, 8. Since it goes in pairs, I usually count by 2. So this is all the valence electrons I have. Nitrogen's happy, he has an octet. Hydrogen's happy, he has his shell full. So everybody's happy. And now you just have to, if it's an ion, you have to put brackets and the charge it is. So if it's 2 minus plus 1, whatever it is, you have to put the charge associated with it. Does that make sense to everybody?
Yeah,
lose
but
it?
he
Yes.
didn't talk about that yesterday, I don't think.
What?
I said, it makes sense, but he didn't talk about that yesterday.
Oh, he didn't? I thought he
No,
went
the
over the Lewis
brackets.
diagram just like very briefly.
He did,
He
but
did,
he
but
didn't
he
talk
didn't
about
mention the brackets.
yeah.
Oh, Okay, yeah. He will probably go over it into a little bit more detail, and he'll probably mention this. Because you do have to it's not like, I guess, super important, but it's kind of important because that's just saying that, like, okay, we have one less electron now. So that's why we only have 8 here. You know what I mean? Because if you
Okay.
like, if you did the math like correctly without, like, if you didn't have this plus sign, then technically you would have 9. You know what I mean?
Yeah. Yeah.
All right. Ooh, dang it. Clear all. Oh, that's how he does it. Okay, I get the hang of this. That's dope. All right. Let me share my screen again. I mean, I found the Lewis diagrams to be one of the easiest ones,
Mhm.
but it does take a little bit of practice. Do you guys want to do these practice problems or nah? I'll leave it up to you guys because honestly, this will be on our next test, but won't be on this one.
Now let's do something else.
All right. You're gonna have to know this, but not for this test. So I built this PowerPoint before, like, after he told me that all this stuff was gonna be on the test, and then he tells me, well, we're not gonna cover some of the stuff. So
Yeah.
like wedge and dash, you guys haven't covered. Molecular geometry, you guys haven't covered, so it won't be on this test. Oh, I
That
did
was
see a
old.
question on the first time. This was a right-in answer in your own words. I will say that.
This is on
Um,
this exam?
Yes, on the practice
Oh,
exam.
okay.
However, I'm not sure if he changed that or not, so I don't know. Because when I looked at it a second time, it was gone.
No, I had it on my practice exam when I did it yesterday.
Okay, then yeah.
Okay.
So he has like a whole bunch of different questions. So like it's kind of random. Sometimes you'll get different questions, like similar questions, but different at the same time.
Yeah.
So you guys got to really know this one. I did see this one on there, but I think he deleted it because I never saw it again, or it just maybe changed. You got to know this for sure. The law of conservation. Conservation.
Conservation.
This is basically what it is. Neither matter or energy can be created or destroyed. What you put in, what you must get out. And this one, I could try to explain it to you guys, but I understand it as ratios. So what I would do for you guys, if you guys want to know this, like I said, I never saw it in the practice exam again, but it can be on there. It just could be on yours and not on mine or my version of it. So I would YouTube this one because I understand it as like ratios, but I don't understand it enough to explain it in a way you guys will, unfortunately. Sorry, guys.
Okay. Yeah, we could just look it up in the book.
Yeah. But he does have some conceptual based questions on there, which has to do with the theories or laws. You guys should know the difference between chemical and physical changes, right? Like the chemical change is when you're changing the chemical part of it, like ammonium to ammonia, and the physical change is where the chemicals are still the same, or like the chemical properties are still the same. Wavelength and frequency. So the wavelength, this is the distance between the top of each wave. The frequency is the number of complete waves there are. I didn't really see any questions about wavelength on this test, but it could just be, like said, not on mine, and could just be on yours. Did you guys see any?
I didn't see any.
You guys didn't? Okay. Then he might not have it on this test. He'll probably have it on the next test. Okay, so I noticed that you guys need to start getting the habit of basically solving for the variable, right? You're taking the some of the equations at like face value, And so that's why you guys kind of have to think about what you're looking for, think about what you have, and then solve for that variable. Like Q equals MC delta T. Could have put the delta here. Couldn't, for some reason I could put a triangle. Or you could do M equals Q divided by C delta T. So you guys have to be familiar with at least some of the algebraic rules. Here's a little bit about the thermal chemistry.
Oh, the endothermic, the exothermic.
Yes, I believe he does have some questions about that on there too.
Yeah.
So the potential energy is the energies that something could possibly have just due to its like the position or composition, like what it's made of. Kinetic is energy something has while it's in motion.
Yeah.
And you guys got to remember though, like the reason why, you know, like when he was talking about the Q water equals negative Q metal, it's because the metal is transferring the heat to the water. So the water is heating up and the metal's cooling down. So it's losing heat. So that's just basically what's all that's happening is something is absorbing the heat and something else is releasing the heat, if that makes sense. At least that's how I remember it. So I do have a couple practice problems that I wanted to share with you guys. Let me, hold on. Ooh, oh, my foot. Damn. Okay, let's do this first one. Dang it. Ah, dang it. All right. So one of the first things I do when I'm looking at a problem is I always look for what is the question asking for specifically. Because you could have a whole paragraph and there will only be one question, one thing you're looking for specifically out of all that data. So for this one, it's how much energy was used to heat copper. Right? We're given the grams of the copper and we're giving the initial and the final. So I'm assuming you guys should already know how to use that equation because this is just taking that equation like Q equals MC delta T, right?
Yes. So if it's in Fahrenheit, we have to convert it before we even do the, what is it, the final minus the initial, correct?
Yes, yes.
Okay.
Typically, most of the time, when you use equations, especially in chemistry, it's going to be in Celsius or sometimes Kelvin.
Okay.
Like I know the ideal gas law, which you will learn eventually. It's going to be in Kelvin, so even if you're in Celsius, you still have to convert it. But for the Q equals MC delta T, Celsius is okay. Because of this right here, like you have the biggest reason why you have to convert it is because you have to make sure all your units cancel out. This Celsius is going to cancel out with that one. Those grams are going to cancel out with that gram. And then so you're only left with calories, which is what you're looking for. Oh, dang it. How did I do that?
Oh shit. Okay, no.
All right. So we'll just do this real quick.
Mhm.
But you guys,
So
do you guys have an understanding of this?
yes. So your temperature will be 60 if you do the final minus initial. And then for Q equals MC delta T.
Ooh, you can't draw a triangle. Delta T is going to be 60 degrees Celsius. Ooh. Yeah, that's tough. Hopefully you guys are getting what I'm saying or trying to write down, attempting to. All
And
right.
then go to 5.0 grams times 0.092 cal over gram Celsius
Times 0.092 calories per gram times Celsius. And then you'll just multiply that by the delta T. And
And
whatever
you'll
you get will be your answer.
7.6 cal,
7 point, I'm sorry?
27.6 cal.
Oh, 27. Okay. So 27.6. But how many sig figs do you think we need?
I was just gonna ask that.
Yeah, sig figs will always matter for any equation or anything you have to do. That will-
1 6
I'm sorry?
32.
1, 2.
2.
Oh,
Yeah, I'll
2.
be 2 because of this guy right here.
Mm-hmm.
This is 2 as well. And I mean, usually though, sometimes I don't know if this will count, to be honest. Sometimes
That's
we,
why I was like confused. I didn't know if that would count as just 1 sig fig, and we'll just do the 30 cal.
yeah, usually though, like, because that's the thing though, sometimes it counts, sometimes it doesn't. So we'll just have it count this time.
Mhm.
Usually, like though, I will say, like, given numbers like this guy, specific heat capacity, that's like an exact number, basically. So usually for like exact numbers, I guess you could say, the sig figs don't count.
Okay.
I've always based it off usually like the mass or something, or milliliters if I'm getting milliliters or stuff like that, because those are usually more measurements. But technically, temperature is a measurement, so that's why I'll count it.
Okay, so for the exam, we should base it off the mass
Or measurement, yeah.
or the measurement.
Because like for that problem, that practice problem you had, you were given milliliters, and you had to
Oh,
convert
yeah.
it from milliliters to grams using density. Okay, well, what was the answer again? It was 27.
27.6.
27.6.
27.6. All right.
It'll be 28. The sig fig.
But if we're doing the right number of sig figs, 28. And then you have to make sure to put calories or grams, whatever it is you're looking for. That will matter.
So if it gave us a specific heat for so say for instance, they said the copper went into water
Mhm.
and they gave the specific heat for the water, we would then have to do the Q metal equals, or what is it? Q metal equals negative Q heat, or something.
Yeah. So if this is like, let's say the water, right? Then, or we could just say this is the metal and the water will just be the negative of that. Like if,
Oh, okay. So if
you
they
know what I
wanted
mean? But we'll say this is the water and the metal will be -28. Yeah, it will be the same exact number, just a different sign. So if
Okay.
one's positive, the other one will be negative. Everybody got that?
Yeah.
I do have one more problem I wanted to work out with you guys. Just give me one sec. Oop, wrong one. Okay. Share screen, whiteboard, share. I wish I could use that whiteboard. I don't know how to connect it to my computer. Okay. So now this one, you're actually not looking for the temperature or the heat. What do you think you're looking for?
We're looking for the specific heat capacity.
Mhm.
How hot it can get.
Yeah.
So for that,
But how would you set up the equation?
so we have. Would we divide it then?
Divide by what?
Would it be M and the delta T divided by the, wait, hold on. Divided by the calories?
Yep.
Okay,
So it'll just be C equals M delta T divided by Q.
okay.
And everybody else, you guys know how we got there, right? I don't know if they're paying attention. Brenda, Cassandra, DJ, Ivan, Janet, Jennifer, Julissa, Wani, Yesenia.
Yes.
What's up?
You guys all understand where we
Sort
got-
of.
Yes.
What do you mean sorta? You said
Yes.
So this is recorded, so we can go back and watch this, correct?
Yes, it is recording. I believe. I don't know. I think
Yeah.
Dr. Henry has it automatically to record because I just use that same link he already has.
Yeah, it's recording up there.
Yeah, it's recording.
The only problem is though, I can't exactly post it. I'm not sure if it will automatically upload. But DJ, I was gonna email you this PowerPoint though.
Okay, that's perfect, thank you.
Okay, for just to clarify those, this is the equation that you started with, right? Q equals MC delta T. And I'm sure you guys are familiar with it because you had that whole lab that with a lot of questions using this equation.
Got it.
So what the only thing we're doing this time is solving for C. That's why I'm saying like using, you have to understand the algebraic rules. Because you have to be able to solve for the other variables. Oh, actually, you know what? This is backwards. See, this is why I should have started it using this. But technically it's supposed to be Q divided by MC delta or M delta T. Because all you would do is you would divide both sides by M delta T. So you would divide this by M delta T. And then this will cancel out with this. And this will cancel out with that. And you divide this by M delta T. And then now you, oh, dang it, did it again. Now you're only left with C. which is what you're solving for. You're looking for the specific heat capacity. And then you just plug and chug. You just plug in the numbers that you're given.
So 10 cal would be on top, and then you would have 3.1 grams on the bottom times 17.9 Celsius.
Yep.
Okay.
Grams times 17.9.
Did I do it wrong?
You can't write on here, but I try.
I don't know if I, hold on. 45, 55.
What does that say on the bottom? Does that say 17.9 C Celsius, right?
Yeah.
Okay.
Sorry, my writing is so terrible on these. It's very hard to write with a key like a mouse instead of like an actual pen. I wish I brought my iPad with me. I could have joined the Zoom meeting on there, but I didn't think about it.
So the answer for that, hold on.
Oh, it's supposed to be 10.0. Oopsie.
Let's see. So you would have, I don't know if it's right. So it'll only be 266. So would it be 0.18?
0.18, yeah.
Does that look right? And then would it be cal
Cal, what else?
per gram Celsius?
Yep. That's exactly what you would do because none of the units are canceling out here. So you're stuck with all the units technically.
Yeah.
So yeah, that's all you would pretty much do. And does everybody understand how we got there?
Yes.
Is
Yes.
everybody awake?
Yeah.
Yeah.
Mm-hmm.
Yes.
Kinda. All right. Because that honestly though, I will say like a lot of your, especially in the future equations, you're gonna have to do like with the ideal gas law, like PV equals nRT. You're not gonna be solving for just one thing. You're gonna be solving like depending on the information you're given, you're gonna have to know how to work that equation out to solve for that variable you're looking for. So if you're solving for n, which would be represent the mass, you would have to make sure you know how to do you use the algebraic rules properly in order to solve for it. And these other questions are pretty much the same as we just did, so I don't think we need to cover that. You guys seem to understand it, at least the ones talking, so. All right, so for some of the dimensional analysis problems, and I get that, I made the same exact mistake. I would look at the problem as a whole, freak myself out, and then be like, nah, I'm not doing this. I've done it on a test before where I'm just like, nope, I'm not gonna bother trying. Because if you look at the problem as a whole, instead of breaking it down piece by piece, it could be quite overwhelming. So what I do is the first thing I always look for is what is the question specifically asking? Is it asking me to find the how long it will take in hours, or the mass, or how many milliliters, or something like that? What is the question specifically asking you to do? And then that's when you read the information given and you'll find what you need and what to get where you're going. And then you just break down the problem step by step. So I do have a couple of examples here. Where's one I wanted to do? Okay, we'll do this one. Don't worry, guys. I'm almost done with my PowerPoint. I only have like one more slide after this, so it'll be over. So just bear with me here. Okay.
Is he gonna have a problem like this on the exam?
He did have a couple conversions, yeah.
Okay.
On mine though, they seemed really easy from like grams to milligrams or kilograms, stuff like that. However, like I said, it's like some sort of algorithm or something, and he has like a whole bunch of questions. So like for each one, for each individual person, it might be different.
So it's not gonna be like the first exam with the
Not-
open-ended question?
Oh, you're talking about this one? Hold on. Are you talking about this one?
Oh,
Because
yeah.
I took this from your first exam.
Oh, yeah, I did not even.
Oh, yeah.
I know,
The
he told me
second
that a lot of
question?
you guys didn't answer it, so that's why I was gonna review it, because I don't know if there's gonna be something like this on your second exam. Not that I saw on my practice exam. Usually the problems were simpler, but if it's not in the exam, he will for sure have it on the next exam or possibly even the final. So you guys, that's why I wanted to review it, because so that way you guys could be prepared for the next time. So you guys could at least try to answer it, because I know a lot of you guys didn't even try to answer this question. And I mean, I feel it. If I was
It was
taking the
just
test, I probably wouldn't want to
confusing.
answer it either.
Had too much going on.
I know.
I just haven't got it graded yet. So like, I don't even know if I got it right.
Yeah, he said he's still working on it, but he did tell me quite a few of the students when he looked at it, just didn't answer the question.
So I actually had mine graded, but I got points, but I don't know which ones I got right. And I told them, how are we gonna find that out? Like, if I did it right or wrong, or if I got half points on it for the gallons and going from one place to another.
I think he grades that himself and then he puts the grade in
Yeah,
because it'll probably
I think
say
she's trying to
partial.
figure out like what she got wrong, like what for that problem she answered it, but she wants to know like what did she mess up on.
well, if he graded it, was there a grade on that problem?
No, my score just went up, and he told me that it's because he's still grading other people's papers, but he didn't quite really answer how.
But you did wrong.
Yeah, like, are we gonna get like those papers back? Like, is he gonna like give comments? I think he said he's probably gonna give comments about like how, like, what we did wrong. But as of for right now, like, it's kind of hard to see where we went wrong, or if like something through the calculator was wrong. Yeah.
Oh, okay. Yeah, because each section had three certain amount of points, and he had all this was all in one problem. So, yeah, I'm not sure. That's his job. So, I'm not happy, but I didn't even look at the test, to be honest. Like the your guys' past test at least. What do I need? Oh yes, I need this, and that. Okay, so it's already here. So how I would go about the problems usually is like I said, the first thing I always do is what do I need to find? So it's asking me how many moles of sodium chloride are there per liter of the solution. So what I'm looking for is moles per liter. Moles per liter. You guys know what moles are, right? It's a unit of measurement.
Mm-hmm.
So this is what I'm going for. So now that I look at like the information, give it to me. Now this is a really simple problem. But usually like if it's a much longer problem, I would like break down the information to try to figure out like, okay, if I have this information, how can I get from this to where I need to go, which is here. So sample of seawater contains this many grams of sodium chloride per milliliter of solution. And I want moles per liter. So I have to convert the grams to moles and the milliliters to liters. So I'm gonna start with the first one by doing 0.05 grams sodium chloride and CO per milliliter. And I'm gonna go with I'm gonna just convert the grams to moles first. Do you guys know how to do that?
I want to watch you do it.
Okay, did
Yeah.
you not cover this? I could have sworn he did.
Honestly, it was a long time ago. It was like 2 weeks ago.
Oh, okay. So you need a refresher. All right.
I do. 'cause
So
I-
we're gonna have grams on top or bottom because we need to cancel out the grams.
the grams for sodium. Okay, okay.
And we're gonna want moles on top, right?
Yeah.
All right.
Mhm.
Now, remember when I said the periodic table is grams per mole. So for this, if you're going from grams to moles, you're gonna want you're gonna need the periodic table, like the mass from it. But it's not gonna just be the mass of just one thing, it's the mass of the whole thing. So it's gonna be the mass of the sodium plus the mass of the carbon, or the, sorry, chlorine.
Okay, so you would do the 22.990 plus the 35.445.
Yep.
Okay.
So whatever that is, I don't want to write that out because that's
22.990 plus 35.45. 1 second. $58.44.
58.44. We'll just do 58.
Yeah.
Okay.
Damn. Can't even draw do an 8. All right, there we go.
So that number gives you the, so that'll give you the total
number
mass.
of grams.
Okay.
And then it's always going to be over 1 mole. So it's 58 grams for every 1 mole of sodium chloride, if that makes sense. Because remember when I did on my slide, I put X number of grams for every 1 mole. That is the, and the grams is just going to be the mass off the periodic table.
Mhm.
So if you just, let's say if you just had chlorine, it would be, what is it, 35.45?
Yeah.
We'll just say 35. So it'll just be 35 grams for every 1 mole if it was just chlorine.
What if it was like sodium, and what if it was like NaCl2?
Then it would be, so you would have the mass of the Na and then the mass of Cl, but times 2.
And that would still be 1 mole?
And it'd still be 1 mole, yes.
Okay.
It's always going to be over 1 mole. However, if you like you said, it would be this one for this one. If you have 2 chlorines, it'll be 35 times 2, because you have to you have to basically do the addition of every single element. So if you have like 3 oxygens in there, it's going to be
It's gonna be the oxygen
16,
times.
yeah, 16 times 3, or 16 plus 16 plus 16.
Okay.
Yeah. Because whenever you do the mass of a compound or molecule, it's the whole mass of everything added together, of all the elements.
Okay.
Yeah, so let me erase these.
Should we just round up before we plug it into the equation?
I mean, I would,
Okay.
because it will make it a little bit easier for you guys. I always did it before I plugged into the equation.
Okay, so now the NA cancels out.
All right. So now that we have the grams canceled out,
We need to cancel out the milliliters.
and then we just cancel out the milliliters. SCL.
So we need
So-
to figure out.
And do you guys know how to cancel out the milliliters?
Milliliters have to go up top, most have to go on the bottom, so we'd have to figure out we'll have to convert. Are we converting the 58 to milliliters or?
No, you're just changing this milliliters
Oh,
to liters. Because what you want is moles over liters. We have the moles on top. We just need the liters now.
okay. So milliliters over liters. So we'll have to figure out how many milliliters are in 1 liter.
It's 1,000.
So 1,000 milliliters for every 1 liter. And that's pretty much it. Like I said, this equation or this problem was super simple. I know like Dr. Henry will not have as easy problems usually. They're usually more complicated. But this will cancel out with this. And now you have what you need, moles per liter. That's why I always look for what I'm looking for specifically first, because it helps me like, because Dr. Henry loves to put extra information that you don't need in there. So it helps me kind of narrow it down of what I do need. Does everybody understand that?
Yes.
Yeah.
Yeah.
Yes.
Let me go back to my PowerPoint.
Could you do another one with the moles?
Yes. Hold on. I have a. See, slow down for the other one. Oh, this will work. Whiteboard. Okay. So a doctor orders that a patient, oops, that's a typo. Oh well. That a patient receives 1.5 times 10 to the negative 3 moles of sodium chloride. The only solution available contains 1.0 grams per 100 milliliters of solution. How much of the solution should the nurse give the patient? So it's asking for solution. Typically, oop, my bad. Typically, I will say solutions are usually moles per liter.
So just saying, whenever there's a mole, it'll be moles per liter as the what it's going to combine with. That makes sense.
Wait, I'm sorry?
So usually if there's a mole, it'll be mole per liter every time.
No, not every time.
Okay.
So if it's just given moles, like this one doesn't have the per liter. It will tell you if it's going to be per liter or per something, you know what I mean? But usually if it's like what is it? Dang it. It's not density. Concentration. That's the word I was looking for. Usually if it's concentration, it will be moles per liter.
Okay.
And actually this one, I'm sorry, since it's asking for solution, it's actually asking for the like how many liters. Like this.
Milliliters.
Yeah. But you have grams here and you have moles here. What do you think I'm gonna do? Because if you want just milliliters or liters, it's not very specific, so you could either one will be fine. However, I will say on Dr. Henry's test, he'll be a little bit more specific. he'll tell you if he wants milliliters or liters, or if he says something about concentration, it usually means moles per liter. Densities grams per milliliter. You guys should know that. But anyways, so you have grams here and moles here, and you need to cancel these guys out so that you're only stuck with this, right? But these are two different units. That's the problem. So what do you think? What do you think you guys are gonna do? Wait, dang it. That's right.
Could you do moles per liter and then liter to ml? Or
Great, moles
Would
per
you do
liter.
the 1 point, would you do it over the 1 gram?
For what?
The 1.5 times the 10 to the negative third power over 1 gram, or
Not necessarily. Because I mean, because what you have to do first is convert those grams to moles. But the only way to do that is using the mass from the periodic table specifically. So we're going to need the mass of the sodium chloride to convert it to the moles.
so we already know that's 58.
So it's supposed to be 1 mole for every 58 grams. Right. Why doesn't that does not look right? Because you'll be stuck with grams in the end, and that's not what you're supposed to be. Oop. Okay, yeah, I see it now. Sorry, I started off the problem the wrong way. This will be grams per 100 milliliters. Then it'll be 58 grams for every 1 mole. Oop, 58 grams for every 1 mole. I will say though, you're gonna have to start getting in the habit of not only putting the unit of measurement, like whether it's grams, moles, or whatever the case may be, but you're also gonna have to starting putting the compound you're using, like NaCl. So I strongly suggest you guys get in the habit of doing that, because that will be extremely important, especially when you do like the limiting reagent and you're doing mole to mole ratios later on. You're going to be canceling out certain compounds with each other. So it's kind of important so you can keep track of it. And Dr. Henry will dock you down points too if you don't. So now you're given, so now you have the, oops, where is it? Oh,
Now
wrong
the
one.
grams will cancel out.
So yeah, you have the grams cancel out. Now you're with the milliliters per 100 or moles per 100 milliliters. But we want to change the milliliters to liters.
So 1,000 up top,
Mm-hmm.
that 1 on the bottom.
Oop. And then you have 1 on bottom. All right.
And that's just for 1 mole, right? So we'd have to do it. I'm confused. Would we have to multiply it by the 1 point?
Yeah, to get rid of the mole. Put the mole
Yes, but what
bottom.
I was gonna do is that's why I'm talking about breaking it up. Because for some questions, you have to kind of have to do that. Like for this one, so I will say just solve for this, and then you'll have moles per liter, and then you'll do another
Oh.
dimensional amount analysis problem, so you can cancel out the moles.
Oh.
Because if you keep going straight this way, you're gonna end up with the liters on bottom, and so that will be the number over per liter. And if you want like the number in liters, it has to be liters on top, basically. Where's my annotate? You guys can still see my screen, right?
Yeah.
Okay. So you guys have a answer for me? For this? So that'd be,
So it'd be 1,000 moles up top and then 5,800 liters on the bottom. Oh wait, hold on. I forgot to divide it.
Would it be 5800 on the bottom and 1,000 or 1,000 on top?
yeah.
So it'd be
But
0.
then you would, but then you're gonna divide the two, so that way you're stuck with just 1 liter on the bottom. Or
So-
it will be 1 mole on top, sorry.
Oh.
So it'd be 0.17. 172.
So it'll be 0 point,
Could you do 0.17?
0.17.
Could you stop there? With 2.6?
Yeah, that's fine. You could just do that. So that's gonna be moles per liter. Moles per liter. There you go. And now what you would do is you would use this to cancel out those moles, but you just switch it. So it's gonna be liters on top, because that's what you're looking for. And then it's gonna be 0.17 moles times the 1.5 times 10 to the -3 moles.
Wouldn't it be 0.17 mole liter on top?
What do you mean?
Like, why couldn't you just multiply straight across, like the 0.17 times the 1.5 times 10
Yeah, you
to-
can do that.
Oh, okay.
Oh, no, technically, sorry, you can't. Because you need the liters on top, like, because right now, if you just multiplied straight across with the 1.5, you're gonna end up with moles squared per liter. Yeah, you need at least one of the moles on bottom and the other one on top. So I mean, technically you could do it. It's just you would just have to switch, make sure that you're technically dividing the moles, not multiplying them. If that makes sense. Does that make sense to you guys?
Yeah.
Yes.
But either way, it's just you need liters on top, and then you'll have 0.17 moles. And then you'll just do, and then you just multiply that by the 1.5 times 10 to the whatever it is, -3 moles. And see the moles will cancel out here. And since you have your liters on top, you'll end with liters.
Oh, I thought you wanted that moles per liter for the solution.
Yeah, honestly, that's what I said
So-
at first, and I confused myself, but technically it's just gonna be liters for this problem. So what, somebody have a question?
No, it's okay.
No?
So
So
how
you-
did you determine that they're asking it in liters?
Because honestly, I just happened to have, I Googled some of these questions, so I already knew that.
Oh,
Because I have the answers and the questions, you know what I mean? However, don't worry, Dr. Henry, he should be a little bit more specific. Or he usually is a little bit more specific on what he's looking for. So if it's like liters, milliliters, he'll tell you that. Or if it's grams, moles, he'll be specific on what unit you're actually gonna be looking for usually.
okay.
But typically though, sometimes might say find the mass. And usually if you're given, that will usually be like given in grams. You know what I mean? Or volumes, like usually milliliters. But most of the time he'll be specific on what you need to find.
Okay.
So everybody got that?
Yes.
Yeah.
Okay, there's one thing I wanted to point out. You guys know what this is? S to the -1.
No.
No.
This is 1/seconds, which is also hertz. I'm only telling you this because it will show up. It could show up on your test like this, or like this. But since you guys don't really know the rules of like exponents and stuff like that, that's why I wanted to clarify that with you guys right now. Because that's kind of important because it could change it up. Yeah, I have to charge my laptop. Hold on. My laptop's gonna die. Hold on. Let me check to see how much battery I have. Give me 1 sec. I gotta plug in my laptop before it dies on me.
You're good.
Oh, there it is. Well, I don't really need this to be honest. All right. Okay. So they want to express to you guys that there's certain rules in algebra and stuff that you learn that applies to what you're doing in chemistry. The rule of exponents being one of those things. So like these are all the same thing. S to the -1, 1/s is the same thing as hertz. And you could see it, you could possibly see it one of these 3 ways on the test. So I want to make sure you guys know how I'm getting this right here. So you guys know that if you have something like, let's say grams over grams, they cancel out, right? Do you guys know why that is? I'll take that as a no, but it's because it's like grams to the one, grams to the one. And when you're dividing exponents, you subtract. So it'll just be 1 minus 1 equals 0. The reason, like, for when you did the centimeters, it was centimeters times centimeters times centimeters. Here, let me do that. Centimeters. I know one of the problems is some of you guys kept putting centimeters, but it's technically not just centimeters. Because centimeters is distance, cubic centimeters is volume. And so this is all 1 that has a 1 there. I mean, honestly, anything to the 1 is just the same thing. Like if you have 2 to the 1, it's just going to be 2. So you never have to put the 1. Same thing like if you're dividing or multiplying 1, you don't usually have to put the 1 because it's going to be the same. It's not changing the answer at all. But anyways, when you multiply with the exponents, it's going to be 1, you add them. So it's going to be 1 plus 1 plus 1, which is going to be cubic centimeters. That's how you're getting that. Does that make sense?
Yes.
Okay. Like, because that will make a difference, because there's times where you're going to have to multiply, the units of measurement, and you guys are going to have to know that you're adding those exponents up, so you're going to have cubic. I mean, like for these ones, you could just remember if one's on top, the other one's on bottom, they cancel out. But for these ones, you have to know that you're adding up those exponents. And for the reason why this is s to the negative 1 is because of this rule. You're dividing, right? It's going to be 1 over s, and this has a 1. So you just bring that up. If you bring it up here, then it'll just be s to the negative 1, if that
Okay.
makes sense. Or you could
Yes.
think of it as 0 minus negative 1. But it's just going to, either way, it's still going to just be s to the negative 1. I'm only letting you guys know this now because I promise you, you could see it this way. And I want to make sure you guys knew what this meant. It's the same thing as 1 over s hertz. Or you could think of like if you're crossing the line, how I remember if you cross the line, you change the sign. So if it's positive down here, it's going to be negative up here. And if it's negative
Okay.
up here, you put it down here, it's going to be positive. Although he doesn't have any electronegativity. He doesn't have any of the wavelength and frequency, and usually hertz has to do with frequency. So he doesn't have any, it doesn't look like he has any of those questions on your test, but I said mine could be a little bit different. Okay. And whoa. Man, this is a problem. Swear he loves to give you the hardest problems. He always does that to chemistry though. Anyways. How many of you guys actually attempted this problem?
I did.
I just want to see if I don't know if that's the exact question that I had, but I honestly feel like I was right, which I might have not been, but I want to see what you guys do.
Yeah, I think that was the exact one I had. No, wait. No, it wasn't. I had 0.0100 for the gallons.
But the question was still the same, wasn't
Yeah,
it?
it's still the same.
Yeah,
It's
very
just like
similar.
different numbers.
Mm-hmm.
Oh, okay. Yeah, so the process of how we work it out will still be the same.
Okay.
So are you guys feeling pretty good about this first part? Or should I go over that too?
You can go over it. I just want
Okay.
I want to make sure I did the steps correctly.
Okay, that is not a problem. Let me just copy and paste this. Okay, and for this last part, you guys don't need me to cover this, right? Because you're just changing the temperature from Celsius or from Fahrenheit to Celsius to Kelvin. You guys know how to do that?
Yeah, that
Yeah.
was
Yeah, those.
All right, perfect. because this will be the last thing we cover, and then I will let you guys go.
Okay.
I will be in the tutoring center at, from 12:30 to 2:30 for those of you who want to stop by. I know some of you guys live out of town, so I'm assuming you guys aren't going to drive out here, but that's cool. So if anybody who lives in town wants to stop by, I'll be there.
Okay. Yeah, I think I might stop by.
Yeah, not a problem. It will start at 12:30.
Okay.
You might not want to show up a little early because my happy butt will not be there.
Okay.
I
I
mean, no,
still
it's just
gotta
a little bit.
drive. Okay.
Oh, I feel that. All right. Oh, wrong one. Wait, Magdalena, I thought you live in town. You don't?
Yeah, I do.
Oh,
I was saying I still have to drive there, so I'm probably not gonna show up till like 12:30.
I feel
I
that.
have to. Yeah.
Yeah, I'm gonna go home and probably eat some food. So thankfully I get out earlier. All right. So for the first part here, ooh, and label them. So this is 1, this is 2. And I ain't gonna lie to you guys, I was working out this part right here, part 2, myself at first, and then I didn't completely finish working it out, but I realized I was going in the wrong direction. I started in the right direction and then somehow I veered off and started going in the wrong direction. So I actually texted Dr. Henry, who was like, hey, I know a lot of the chemistry students were not doing very well on this problem. So I wanted to review it, but I want to make sure I'm doing it right first.
Yeah.
So I did
I
actually.
only did half of that problem.
I knew
Huh?
that there were 2 parts to it. That's for sure. I broke it down just like this. One part and I did that first and then the other part, obviously.
Yeah.
Another
Yeah, I was
part.
stuck on the second part. I didn't know where to go from that.
For like this one right here.
Yeah, like I started solving the first portion of it, and then when I got to the second portion for it, like I was just stuck, so I just quit.
There was just so many things to factor in.
Yeah, I know.
So for that first one, you would do the 12 gallon. You'll put that first.
So you're gonna first do the 12 gallon, right?
And then you're
And
gonna
then-
do 1 minute. Well, yeah, you're gonna do the minute up top, and then the 0.25 on the bottom.
Oop.
On the
Wrong
bottom,
one.
I was like, girl.
Oh, I was like, damn, I did fuck that up.
I was, because I'm like, yes, I'm getting there.
Yeah, no, you guys are right. See that first part, I figured was pretty simple that you guys,
Oh, it was so easy.
yeah.
Like,
I mean, this one was the one that was like, wow.
I was trying to cut some words out. I was like, I don't care about this. I don't care about this. 0.250.
0
Mhm.
and then a gallon. So you cancel out the gallons.
Yeah.
Oop.
And then you have to convert minutes into hours.
Yeah.
And you guys should know the conversion for that, 60 minutes for every 1 hour, right?
Mhm.
Okay.
And then
I was like, everybody knows that one.
yeah, that one was simple. And then you minutes cancel out and you're just left with hours.
Mm-hmm.
And then Magdalena, you want to do the math?
Yeah, honestly, I don't have a
Oh
calculator.
my god.
Yeah, I don't have my calculator.
So
12. Oh, you gotta do 60 times.
my bad. Hold on. Oh shit. I'm fucking this up.
Mhm.
My bad. Hold on.
You want me to do it or?
That's good. 16.
1.5. So 12 divided by 1.5. I'm getting 8.
8.
Yeah,
That's what I got the first time I worked it out too.
Okay,
Yeah.
8 hours. Okay, I think I did the first part right.
Mhm.
Yep. So 8 hours. So I'll just put 8 hours right here
Yeah.
so I could erase my work and then use the board again.
Then this one on my scratch paper, my math was just everywhere, so I'm not even sure. But I got an answer.
But how did you guys start it out? Because my problem when I originally was trying to do it, I was trying to do a long dimensional analysis all at once. However, when
No,
I did
I
that, I
got
noticed all my units were canceling out. So you're not supposed to do that.
No, I actually didn't do that
You-
at all. To be honest, I was just doing like I was factoring in what was it? Would it make it before it?
So I start, okay,
Oh,
so let me
gosh.
hit that.
I don't even remember what I was doing.
So I think I did the, oh, well, my question was different. I think I did the 12 gallons. That was gonna be on the left-hand side, and then he has 75 miles per gallon. So I did the 75 over 1 gallon so that the gallons could cancel out for the first part. I don't know. if
So
that's
you
right.
had the 75 miles per gallon instead of the 32, like right here. Because the 75 for this question in particular is miles per hour.
Oh, wait, shit. I was looking at my worksheet right now, so.
Because I mean, he that's very possibility that he said 75 miles per gallon on yours because he does
Oh, no,
change
no,
the
no, no.
numbers.
It was, it was 25 miles per gallon.
Okay.
So it's gonna be the 32 and then the 1 gallon on the bottom. What was it?
Well, actually though, the problem with that though is from what I remember, you're supposed to do, so you're starting with 12 gallons and then you subtract that from the gallons used that you used.
Mhm.
And that will be, if it's positive, that means you made it. If it was negative, then you didn't make it. Because that means you ran out of gas before you can make it to your destination. And to solve for, damn, that's terrible handwriting. Let me try to fix that. The heck is that?
I think what I did was I figured out what I used in the trip and then how much
Yeah, you
leakage.
have to
Yes,
figure out what you
yes.
used first.
Yeah, that's what I was
Yeah.
trying to do.
Okay,
I
yeah.
figured out everything honestly individually, like how many miles, like how many hours it would take for me to drive 1.1 miles, and then how much gas I was leaking, and I kind of did that. I don't know if that was even.
Yes, exactly. That's exactly what you're supposed to do. I mean, or you can, yeah.
Yeah, I did. There's just so many different things to factor in, and so yeah, I figured that out first.
Yeah, exactly. That's what you're supposed to do. Is just break everything down,
Mhm.
and then you'll have all the information you need because you're given a lot of different information right here, right? So let's say I would start with 101 miles to get how long it takes, because you have 101 miles to travel.
I don't know what the hell.
Oh, that's the thing though. You're not really asked how long it takes.
It
just
says
it's
how many gallons of
gallons.
gas are left over.
Yeah.
Wait, what's in like 3 different questions?
Yeah, but the third one, at least the one I saw, was just converting the temperature in Fahrenheit to Celsius and Kelvin. It was like your car overheats at this many degrees Fahrenheit. What is that in Celsius and Kelvin? But again, your guys' questions could be a little different from what I saw.
The question that you have up here, that's basically what it was.
Yeah, pretty much. I just didn't put the third part on there because it was just converting from Fahrenheit to Celsius. So I figured you guys would know how to do that.
Yeah.
So it's 101 miles. And it could be traveling at 75 miles per hour.
Yeah.
Oops, sorry. You need to cancel out the miles, right? Per hour. So that will give you your number in hours, how long it takes you to get there. And then you would do the 32 gallons.
Okay, I did do that.
Did you guys do that?
Yeah. Wait, hold on. I don't know if my question was different. Well, it was different, but
I did that only when I was trying to find the leakage. I feel like it didn't, when I was doing the math, I feel like it didn't really matter for like the gallons used in the trip.
Well, you have to add them both. You have to figure out how much
Yeah.
you used and then how much you also lost. Because then it says
Yeah.
how much gallons of gas were left over or short.
Yeah, you
Yeah.
have to know how much gallons you used.
Yeah, because if you started with a full tank, you have to take those both into consideration.
No, I'm saying with the 75 miles per hour, I feel like I used that. I used it all. But
Uh-huh.
when I was trying to find just how much gallons in general were going to be used on the trip, I did the 101 miles, and then I did the 1 gallon over 32 miles, and then that gave me the amount of gallons used for the trip. And then I did the other conversion, which I did the one you're doing right now, and then I did the what was it? The time. So I had a time of 60 minutes over an hour, and then how much gallons you're losing a minute to get the amount you would lose, the amount of leakage in the trip.
Okay, yeah, I mean,
Yeah.
I was just doing the order that I was shown in, but you guys could do it in whatever order you want. Doesn't exactly have to be like there's one order to do it in, for at least for this problem. Now there will be some problems where the order does matter. Like you have to solve the first thing to get the next thing, if that makes sense.
Yeah.
Yeah, for this problem though, you could do it in a little bit of different order. You could solve for the you could cancel out the miles first, or you could solve for the time and stuff like that. It doesn't really matter because it's not super dependent on the answer for it,
Mhm.
if that makes sense.
so for the first portion that you're doing right now, what are you finding?
Well, right now I was just gonna solve for the hour because that's what I was going for
Okay.
first. And then I mean there's a number here, but I don't, like I said, I don't have exactly have a calculator, so
How many
But-
hours is it going to take for you to get there?
yeah,
Okay.
because that's how I was gonna use that to cancel this minute out right here. And then
All right, so that'll give you, wait,
I think it's
so we'll
1.3.
do 101 divided by 75.
yeah,
Oh no, because you're still left with that. Yeah. So that'll give you 1.3.
3.5.
0.35.
Because it gives you 1.346666.
Okay, yeah, that works. Technically though, it's only 2 sig fix because of this guy right here.
So just be 1.3.
Yeah. 1.3 hours. There we go. And then
So that's how many hours it'll take us to get there.
yes. Then I use the 32 miles per gallon and the 75 miles per hour. So I'll just do, I guess I continued it off here. So it's going to be the 75 miles per hour.
Run out of space.
So the hours will cancel out. And then you have the 32 miles per gallon. So you're going to have 32 miles for every 1 gallon. And this will be your gallons that you have used. Right?
Oh, okay, hold on. Let me do the 75. Oh, I have to do 1.3 times 75. 3.0. 3.0 gallons.
Yeah. Oop. So that's the one you use, but you also have to take in consideration the what's leaking too.
Yeah.
So you'll just use the same number, like 1.3 hours. And then you'll just, so you'll end up with the minutes. So it's per minute. You could either convert the hours to minutes or minutes to hours. Either way, as long as they cancel out, doesn't really matter. So we know there's 1 hour for every 60 minutes, right?
Mm-hmm.
So we cancel it out. Then we'll have for every 1 minute, you're leaking. Oop. No wonder Dr. Henry's handwriting is so sloppy when he writes on this, like the board.
Mm-hmm. I
He
told him
makes
get a pad.
All right, so it's 0.0250 gallons, right?
Mm-hmm.
And this is how many gallons that you were leaking, right? So whatever answer you get for that, because now you only have gallons left. Oop, let me put
Now
my
you'll have 1.95.
1.9, 1.95. So that would be what, 2.0?
Oh.
Yeah, because we only have 2 sig figs for this one, so 1.95. Is it just 1.95, nothing else after the 5?
Yeah, that's all it was.
Okay, we'll leave that the
Let me do
same,
it again.
so it'll just be 1.9, right?
Yeah.
And then you would just add these two together and subtract from what you started with. So it'll be just adding it by looking at it, it's gonna be 4.9 gallons. And then you just subtract 12 minus 4.9. Is that how you guys did it?
Nope.
Oh, I think I did, but obviously my numbers were different.
Yeah, your numbers might be different. But who said no? Like, how did you guys set it up?
It was completely wrong.
What?
No, the way I did it was completely wrong. I don't know what I did. So I did the 12 gallons times 25, well, the 12 times 32 miles per gallon. And I got how many miles I would get. And I did the miles I got and I divided by the miles per hour.
Oh, I see. Yeah, that's the thing though. You weren't looking for miles. You were technically looking for gallons.
Gallon, yeah.
That's why I always say look at the question, what you're like trying to look for, and see how you could skip from like miles per gallon to just like gallons or just miles or something like that. You know what I mean?
Mm-hmm.
So
Like I said, I was working it out and I was trying to do the whole problem at once, and every single unit I was using was canceling out, and I was like, that's not right, because I was even canceling out my gallons, and I was like, I need gallons. I can't cancel them out. So that's kind of why, like for this one, like this is the ones you kind of have to break up into little pieces. But does everybody understand how I got there? Does anybody
Yes.
have any questions?
Yeah. So then he asks how many gallons of gas are left over or short. Do you add those two numbers up and then subtract from 12?
From what you started with, yeah. So it'd just be so if you add it up, it'd be 4.9 gallons.
And that's just what we use while driving and then leaking, right?
Ooh, dang it. What'd I do? Yeah, Yeah.
Oh, you did this. You went to the second page. If you go on your bottom right-hand page where you see the two
Oh,
at,
hey.
Ooh, okay, I see it. Thank you. I was like, what happened?
Oh,
I
okay,
did
yeah.
not mean to
So
do
you do
that.
12 minus 4.9.
Yeah, and that will be how much you have left over. And Dr. Henry actually did tell me that if it was a negative number, you were short. So that means you ran out of gas on the way. And if it's positive, you made it to your destination. So that's just how much you have left over.
Yeah. Okay. I mean, I feel like I feel confident. I'm pretty sure I did that. My answers obviously were just different.
Yeah, because I figured it would be because you have different numbers, but I did want to like explain it to you how you guys could break it up. I know like Ivan did something a little different. I know he went, I think, what you saw for it first, Ivan? Was it the time or the gallons first? Is he even still here? I haven't checked.
Yeah, he's probably just not. Probably thinking about it.
I don't think he's here. But anyways, either way, like for this is one of those problems where you could do it a little bit differently.
Yeah.
All right. So nobody has any questions?
no.
Nope. Alrighty. Then that's pretty much all I had for you guys. I will email you guys the PowerPoint right now if you guys want to look over it.
Okay, thank you.
No problem. And I will be here in the tutoring center from 12:30 to 2:30 if any of you guys want to stop by, okay?
Okay, thank you so much.
Thank you.
Thank
problem.
you. Have a good day.
You too.
All right, bye.